Our protocol provides a flexible and computationally feasible approach to studying weakly bound molecular clusters and can be readily applied to gain insights into their structure, formation, and abundance.
This technique's main advantage is its efficiency and flexibility in treating molecular clusters at different levels of theory, from quick force fields and semi-empirical methods to rigorous quantum mechanical methods.
Atmospheric and aerosol chemistry can benefit the most from this approach, leading to better models of climate change. However, any field involving molecular clusters can exploit this approach.
For individuals who have never performed this technique, the most challenging steps are the initial program and script installation and their adaptation to the local computing environment.
Students new to computational chemistry can overcome the steep learning curves in using high-performance computing clusters through the visualization of explicit step-by-step instructions.
To obtain a minimum energy structure of isolated glycine molecules for use in a genetic algorithm configurational sampling, open a new session in Avogadro and click Build, Insert, Peptide, Glycine, and Insert Peptide to generate a glycine monomer in the visualization window. Click Extensions and Gaussian and edit the first line in the text box as indicated. Click Generate and save the command file as glycine.com. To obtain a minimum energy structure of isolated water, open a new session in Avogadro and select Build, Insert, and Fragment. Enter water into the filter text box, select the water file, and click Insert.